Hey everybody. The last thing that we're going to talk about measuring before we get into the physics of motion is measurement of time. Now for most people, they're going to take a look at this and their immediate response is, I know how to measure time. I have a stopwatch app on my phone. And that is going to become really handy during most of our experiments. But we still need to discuss how we appropriately measure time, the different tools we can use, and talking about something called periodic time. So our objective for this lesson today is that the learner should be able to use devices for an interval of time, and an interval simply means a certain amount of time. So let's go ahead and take a look at our vocabulary. Vocabulary words for this unit are going to be analog, digital, frequency, pendulum, and period. Now these bottom three are going to be new to most people, and let's go ahead and talk about those really quickly. These three right here refer to something called periodic time. And periodic time is measured by using a pendulum. Now pendulums can represent more than just the bob on the end of a clock. A lot of things have pendulum-like motion, but since we're talking about time today, we're going to be dealing with these three concepts in the reference of periodic time. So first, let's go ahead and discuss the instruments that you already know how to use, those being stopwatches. Below I have two examples of stopwatches. One of them is considered analog and the other is digital. Analog has the little needle that goes around in circles. Think like the clocks that you see in classrooms. Those are called analog. Digitals have a readout that tells you exactly how many seconds have passed. Digital ones in general are going to be much more accurate than an analog clock. You can use both of them, but the digital is going to give you a more precise reading. And these are useful for intervals that are many seconds, maybe 30 seconds, 40 seconds, or maybe we're measuring in minutes. We are not going to use these when we are dealing with small intervals of time, and I'm talking like less than 2 or 3 seconds. For those, your reaction time makes too much of a difference. And so we have to use other tools like lasers for small intervals of time because your reaction time is going to get in the way. Now that's all I'm going to say about stopwatches because most of us know how to use a stopwatch, so that's going to work out perfectly fine. Now let's go ahead and take a look at measuring extremely short intervals and using what's called a pendulum. A pendulum is a weight that is hung from a fixed point and it swings freely back and forth, and we call the weight bob. When done correctly, every swing takes the exact same amount of time. Given the actual reality of air resistance and gravity, a pendulum will eventually wind down to zero, but for the first couple of swings at least, they're going to take the exactly same amount of time and they will cover the same amount of distance. So the time it takes to complete one full swing from the left side to the right side and all the way back is called one period. So for this picture that I've got here, if Bob starts here and he has to go all the way over to here and then all the way back, the time that it took for that trip to happen is called one period. So the period can be calculated by by timing the seconds it takes to complete 25 swings and then dividing that by 25. The reason we pick 25 is that it's a good large number, it gives us a good data set, and it gives us a great average period. Like I said, this thing is going to eventually start winding down, so we can't always believe that it's going to be the same amount of time because there are forces acting on Bob to make him slowly slow down. So we take 25 swings, and that's going to give us a great data set. So, for example, you are measuring a pendulum swing. It takes 55 seconds to complete 25 swings. What is the period? You're going ahead and take that 55 seconds, divide it by 25, and that will tell you that it takes 2.2 seconds for one period of my pendulum, or 2.2 seconds for Bob to start way over here, travel this way, and then come all the way back. That's going to be one full period of that pendulum. Now the frequency is how many cycles happen in 1 second. So the frequency can be described as 1 divided by the period, or what we call t. So here's our equation for frequency. The units for frequency are hertz. Now, if I've got any computer people who are currently watching this, we frequently talk about megahertz, kilohertz, gigahertz. Hertz is a measurement of speed in the digital world. For right now, we're just going to refer to hertz as talking about how many cycles can happen in 1 second. The connection does get made in the digital world, but that's for another time. So if I have a period of 5 seconds, what is the frequency? You take 1 divided by 5, and you'll get a period or a frequency of 0.2 hertz. That means that in 1 second, my bob has moved 0.2 of a full swing. So the last thing I'm going to discuss today is an oscillator and oscillations. Oscillators are devices that create vibrations. And we can use them to create vibrations. We can use them to measure vibrations, how many vibrations are happening. We use these tools because we can control the frequency and the period of the vibrations to a very fine-tuned point. So we use oscillators in the lab to simulate certain frequencies. And you can find, if you Google oscillators, you can find a number of virtual versions as well. So that's going to be the last thing. You can go ahead and take a look at the example. All it's doing is, once again, walking you through the equations for frequency and period and how you would use those in the context of an oscillator. So in summary, we talked about how we measure time. You should have gotten out of this that we have analog and digital. Analog being the clock that goes round and round. It starts with a little needle and that just goes all the way around. And digital being the one that most of us are familiar with. That's the one that has the little readout with the numbers, say I'm at 0, 23, 0, 1. So that's a digital readout. This would be an analog readout. We also talked about periodic motion. We discussed what a pendulum was. Pendulums. And we also dealt with things like the frequency, which is a lowercase f. I will draw that better. A lowercase f. And we talked about the period, which is which is a capital T. So this is going to be my frequency. And we measure that one, if anybody remembers, in hertz. And this is the period of a pendulum. That covers just about everything. I did discuss oscillators at the very end. And if you've got those, you are good. Thank you for watching.